Hey, at-home students or students not able to come to class, just want to say hello. Hello Friday morning to you. We are going to finish up 6.2 today, hopefully, and then we'll keep on going here. So good morning and hopefully have a good day. We're dealing with fractions, is that right? Now let's go back just real quickly here in our previous example here, just to connect the dots here. And happy Friday to you, or Friday to you. All right, so cosecant are the issues here. So we have ourselves, not so much fractions, but we have ourselves trig functions in the bottom, right? In your denominator, that's our issue here. And so if we do that, we bring it down to in the denominator. And what we do is we just like algebra. Remember way back in algebra, we had something like this, right? What did you do here? I know it's Friday. We just multiplied by 3 and cleared the fraction, right? That's kind of what we did here. Only thing is, let's flip these around. If this is the case, right here, if it's 3 over x is equal to 6, way back in algebra, in those days, what you had to do is you had to declare that you say x can be equal to 0, like that, and then you multiplied by x on both sides. We good? That's what we had to do to make that happen. Okay, so we do the same thing here. So whatever this is, it can be equal to 0. It's not part of our answer set. If we do get an answer set of that being equal to 0, we drop it. Doesn't make sense. And so now we go on to number 4. Grant, look at that. I stalled long enough. Wow. Come on. You ran over here too. Yeah. And then you're not on the list, so you still have to step out.
I did just do it, so
okay.
You might need to refresh it.
No, you have to look at
Yeah, sorry, bye.
I think we should take a vote as to who, as whether to actually,
Like I think about Monsters Inc. where they all come down and like with the soft. Yeah.
it's just you.
Yeah, they got a big graph-shaped dome.
All right, let's begin. Let's go for it here. So first things first is cosecant. I think we can do that part. So how about 2 sine theta minus 1 is now equal to, I gotta bother some people here. Corinne, all yours here. Cosecant is?
1 over sine.
Dun, 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 dun. And we are in radian measurement. We're just going 1 revolution around. Perfecto. Okay, so off to the side, sine theta can be equal to 0. Scratch that off the list. Keep it there just in case we have y equals 0 later on. And let's multiply both sides by sine theta. Need parentheses here. And sine theta need parentheses there. And that is all gone. How about a distributive property here and there? 2 sine squared theta minus sine theta equal to 1. Oof. All right. Keep all yours to see what you do next. Things through. Give you a hint, something about an x sine squared in there, and then also a sine in there.
Is it 2 sine minus 1 times sine? No, that's the same thing. I'm trying to think.
Yeah, sure. Process. Go ahead. Talk about it, because this is part of talking it through here. Yeah, no problem. Let's see. Anybody else want to help out think things through here?
It involves subtracting the 1.
I think so. Notice you have a sine squared over there, right? Then you also have a sine. It's almost like, feels like this from algebra. What did we do here in algebra? Yeah, subtracted the 1 because we want to get set equal to 0 because you're going to factor. You're setting up for factoring at this process.
I'm like, I said it involves subtracting the 1, and that's not the whole step.
Yeah, so you have.
It is a component.
One small component involves subtracting the 1.
Okay, So whenever you see a trig term squared and then another trig term again, you know you're gonna have to scoot everything over and you have this little setup, which is something squared plus or minus something plus a constant equal to 0. And then we start factoring. So that's right, the magic square. So -1, 2 sine squared theta minus sine theta minus 1. Okay, now we get to do some fun stuff. And if this is sort of too complicated to sort of even look at, go back to algebra. You can always replace the whole trig function with an x. And if you have something that looks like this, I think that's even easier to factor. Haley, there you go. Can you give me at least one factor? Or actually like this, can you break down, this is the way I would do it, just break down 2x squared. Perfect, yeah, absolutely. 2x times x is, you always do the front numbers first to sort of get going. And then the question is, how do you multiply to get a -1 so that when you add things together, you get a negative x in the middle? That's cool, yes, absolutely. Notice that if this guy becomes a positive x, 2x minus x is a positive x. If you have the exact opposite of what you want, all you have to do is just switch the signs. That's all the difference there. So this should have been minus, that should have been plus. We're good? So the middle, you get the opposite of what you want, switch the signs, you are good. So therefore, now I get a -2x, I get a plus x, and I get a minus x in the middle. So let's bring it back to our trig function here. And if you could do it this way, straight, that's cool too. How do you get a 2 sine squared x? Oh, that has to be 2 sine theta. And a sine theta there, are we good? How do you get a -1 at the end? +1 here, and -1 there. So out of curiosity here, raising of hands here, how many would go back to algebra and do it like this just to sort of see the x, just to make sure like, okay, this makes sense. Okay.
Oh, I love it.
I don't know, it's kind of
It
the
depends
same.
on if you see it right off the bat.
Yeah.
Yeah, okay. Uh-huh.
Like I could see seeing it right off the bat and just kind of writing it out without switching, but if I had to work it out, I'd probably go back.
Yeah.
Okay, cool, yeah. So just in case, you can always go back and look at it that way here. So at this point, we're going to split our 2 multiplications so that both of them equal to 0. All yours, go. This guy has to be set equal to 0. This guy set equal to 0. I got to go to the next slide here, so I'm gonna give a little bit of space here. So it's 2 sine theta plus 1. Then I have a sine theta minus 1 equal to 0. Right then, all yours. What should we do over here? Perfecto. Awesome. Divided by 2. We get ourselves sine theta is equal to a -1/2. That is a number on the unit circle. I know that for sure. Yes. See, Georgia doesn't have a book in front of her again, so I can't ask where it's the answer on the unit circle again. I think purposely she doesn't bring her book now.
Adrian is a prophet. I just like to say
He
that.
holds infinite knowledge.
Yeah.
So I'm thinking, let's see, I'm thinking first of all, which quadrants? I like that. Georgia, which quadrant should I be looking at? Yes, some kind of question to bug you.
Oh.
First.
And then tell me why. How about that? So the y value, this is a y value, right? The y value is a negative.
Yeah.
That means it has to be below the x-axis at this point, right? Third and
I was
fourth.
gonna say, like,
Forgot
wait.
that it was negative. I was looking at the other one.
Gotcha, okay. I like that excuse, Georgia. I was looking at the other one. I think I'm
Because
gonna.
I thought that was what you were gonna ask me.
Oh, okay. Oh, what we do over here, right?
Yes.
Okay, gotcha. You're preparing for it. Tricked ya. Adrian, looking at the unit circle, what is this guy here? In radian measurement, right? Radian measurement?
Look at the unit circle.
Wait, which are we doing the left side still?
Yeah, left side still. Because I tried to trick Georgia.
210 degrees or 330 degrees. Is that right?
Yeah, converting to degrees. Sorry, to radian measurement.
Right, 7 pi over 6 and 11 pi over 6.
Cool. 7 pi over 6 is this guy here in quadrant 3. Then we go this way around, and that's going to be 11 pi over 6. Cool. Okay. Georgia, do you want to do this one? Just to prove? Yeah. What should we do?
You add one.
All right. Boom. And I'm looking for, when is the sign going to be 1? That has to be on the unit circle. And that's the only time it's 1 is all the way up here, right? Because that's the value is 1 is the highest it's going to go. And what is the part 2? Okay. Are we good? That is it. Final answer here. In any order whatsoever, it doesn't matter. As long as you have all 3 answers, and there it is.